Good morning, students. Today we are going to discuss about time variant and time invariant systems. Time variant versus time invariant system. Now, by definition, a time invariant system is one whose characteristics do not change with time. For instance, if the response of a system to an arbitrary input sequence xn is equal to yn, then the response of that same system for an input sequence shifted by k samples denoted as x of n minus k should be yn minus k. That is, the output sequence will be also shifted by k samples. To illustrate this, let us consider any arbitrary sequence. This is 0, 1, 2, 3. These are the sampling instance. These are the amplitudes. 2, then 3, and finally we have 4. This is the input sequence xn. The output sequence for this can be represented as 0, 1, 2, 3. I can have the magnitudes over here as 2, 2.5, again 2.5 and 4. Okay. Now, if I shift this particular input sequence by some k sample, let us say by one sample only. So at 0 it will remain 0, at 1 it will remain 1, at 2 it will remain 2, then you can say at 3 it will remain 3, and so on. The output for this sequence will be at 0 it will remain 0, at 1 it will be 2, at 2 it will be 2.5, at 3 also it will be 2.5. So this is x of n minus k, this is y of n minus k. So we can say that first, for an arbitrary sequence xn, we have found the output sequence yn. Then we have delayed the input sequence by k samples to find the corresponding output sequence, which is also delayed by a similar number of k samples. So I can write again y of nk as a function of t x n minus k. Okay. When I delay the output sequence by k samples, I will get y of n minus k. So this also I can write it as y n of k. So if I want to have the system to be invariant, it is necessary that y of n minus k must be equal to y of nk. Only then I can say that the given system is a time invariant system. Next, we move on to impulse response and convolution sum. Impulse response and convolution sum. This is our next topic of discussion. If the input to a system is a unit impulse sequence, that means if I write xn is equal to delta n, this is my input sequence, then the output of the system denoted as Hn will be known as the impulse response of the given system. Now the question comes, how do we represent this impulse response? We can write it as T x of n. Because xn is equal to delta n, we can write this again as T delta of n. Now, we all know that for any arbitrary sequence xn, it is possible for us to represent it as a weighted sum of discrete impulses. That means y of n, we can write it as T x of n. This again we can write it as T, if we take this as a summation from minus infinity to infinity, I can write xk delta n minus k. If the given system is a linear system, then I can again change this and write it as x of k t delta n minus k. Now we have to write the summation sign over here from minus infinity to infinity. Okay, so this we can write it for a linear system. Now the response to a shifted impulse sequence can be denoted by Hn of k. So this is defined as Hn of k is nothing but T delta n minus k. For a time invariant system, we have H of nk equal to H of n minus k. So therefore, the output sequence yn can be written over here as summation of k equal to minus infinity to plus infinity. X of k remains as it is, and this part, this T delta n minus k, we can write it as Hn minus k. This is further represented as convolution of xn h of n. Okay. Next we move on to properties of convolution. So it obeys three properties. First one is commutative law. So according to commutative law, convolution of any two sequences xn and hn can again be written as convolution of the sequence hn and xn. Second property is associative law. According to this, convolution of two sequences, let us say xn and h1n, convoluted with H2n is equal to x of n convolution of H1n convoluted with H2n. And the third one is distributive property. So according to this, convolution of xn H1n plus H2n is equal to xn convoluted with H1n plus xn convoluted with H2n. So these are the three properties of convolution. That's all for today. Thank you.